So in today's class, I'm going to review the properties and how to prove congruency. If two triangles are given, how to prove congruency. Okay. So really quick, there are four methods. One is if two triangles are given, and let's say that the sides are marked, say one mark. Instead of taking numbers, I'm putting marks. Double stroke, and again triple stroke here, That indicates that, let's say that in triangle ABC and triangle PQR, I can say that line segment AB equals to line segment PQ. How do you know? Means you see the sides are marked. BC is having a double stroke and QR is also having double stroke. Therefore, side BC equals to side QR. Let me write maybe little in detail. I can say that say side AB equals to side PQ and side BC equals to side QR, and the third side AC equals to side PR. How do you know? Means the markings are telling me. And here side equals to side and side equals to side and side equals to side. We call this as Sss postulate. That means in two triangles, three sides of one triangle are respectively equals to three sides of another triangle. We call that they are congruent. And next, second postulate is let me take two triangles. Oops, it's really bad. So this is one triangle, this is second triangle. Let's say that this is ABC PQR. Again, I'm marking, say that side AB equals to PQ. Next, BC double stroke, QR double stroke. These angles, these sides are equal. And I'm marking angle B. Please notice that this angle is in between the given two sides, that is AB and BC. Okay. Let's take that side AB equals to side PQ. You can see that these two sides are marked with the same symbols. That means these two sides are equal. And second part is say that angle B. Of course, when I write angle, I need not put the symbol. Just I'm putting the symbol here. Angle B equals to angle Q. Say that is also given. And next, side BC equals to side QR. How do you know? Means you can see that the same kind of markings are given both. Therefore, here you see that side equals to side, angle equals to angle, side equals to side. So we say that by Sss congruency. But the most important part about the Sss congruency, the angle must be in between. This is called as included angle. The angle must be in between. So again, I'm repeating, when you are using Sss postulate to prove that the triangles are congruent, therefore the angle must be in between the given two sides. If the angle is not in between the given two sides, just look at this one, say that here AB and BC, you see that the angle is in between the given two sides. I request all of you to watch this one on a full screen mode. Okay, now let's go to the next page. Here, this time I'm taking again two triangles, those triangles. Okay, I'm going to give you two scenarios, so just let me copy paste this one again here. Okay, So let's say that this is a triangle ABC and triangle PQR. Triangle ABC and triangle PQR. Again, I'm marking with you see that angle B and angle Q, these two are marked with a single stroke. Angle C is double stroke and angle R double stroke. That shows that angle B equals to angle Q and angle C equals to angle R, and BC, side BC equals to side QR. So if you are listing this one and if you are describing this one, we say that angle B equals to angle Q. How do you know? I see the same markings are there, and side BC is congruent or equal here side QR, side QR. And the third one is angle C. Angle C is equal to angle R. So I say that by ASA, that means angle equals to angle, side equals to side, and angle equals to angle. So by ASA congruency, these two triangles are congruent. These two triangles are congruent. But I have a question. Let's say that angle equals to angle, and say that angle equals to angle equals to angle. This time I'm taking some numbers. Say that this is 50 degrees and the other angle is 70 degrees and the other angle is 70 degrees. Now let me label the triangles. Let's say that this is some J, K, L, maybe some S, T, U. Now I'm taking JK, side JK and ST, these two are marked equal. So can I say that these two triangles are congruent? Means let's say that JK, side JK is equal to side ST, next angle K equals to angle T, and angle L equals to angle U. Now, are they congruent means? Then you may get a doubt. Do we have SAA congruency? Means obviously no, but I see that side equals to side, angle equals to angle, and angle equals to angle. So can it be still become as ASA? Means you may get a doubt. The side is not in between the given two angles. You see that these two angles are marked here, and I see that the side is not in between. So can I consider this one as ASA postulate? Means I would say yes. Because if you take two angles as one is 50, the other one is 70, you know that sum of three angles of a triangle is 180. So obviously third angle is 60 degrees. In the same way, can you find the third angle of this one? Means, one is 50, one is 70. Next one is 50, one is 70. So obviously the third one is 60 degrees. Now, do you see that this is 50 and this one is 60, and the side is marked in between those two? Therefore, can I consider this one for ASA? Means yes, you can. Therefore, when it comes to ASA congruency, please remember it is not necessary. It is see here I found 60 degrees. So even if you are not finding the third angle, simply you can say that so here please notice that here is the angle and here is another angle, and the side is not in between, but still can I say this one as ASA? Means yes, you can, because obviously the third angle will be equal to the third angle, right? Instead of ASA, if you want, you can say that AAS, that also works. And the fourth postulate is again a quick reminder. In SAS, the angle must be in between. In ASA, the side need not be in between the given two angles, which we call as included side or included angle. Now, the next one is about the RHS. What is RHS means? Let me finish drawing these triangles. Okay, so I'm taking two right angle triangles. Okay, so I hope you know that what is right angle. One angle is 90 degrees. One angle is 90 degrees. When they say that right angle triangle, obviously the thought comes to in your mind that the side opposite to 90 degrees is known as hypotenuse. The side opposite to 90 degrees is known as hypotenuse. So some teachers prefer to say that this one is RHS, and some teachers say that this one is HL. So these two are one and same. Let's say that the hypotenuse is marked with a single stroke. One of these two sides, it can be the perpendicular line or maybe the base. So here I'm marking with the double strokes. Oops. Oh, so let me mark with double stroke, and let me label the both the triangles. This one as ABC, and this one is triangle PQR. So, in these two triangles, of course, you need not elaborate this one. Let's say that right angle B equals to right angle Q. It is right angle Q. And next, you know what is hypotenuse? The longest side or side opposite to 90 degrees. So let me write in brief. Hypotenuse AC equals to hypotenuse PR. Okay. In fact, what are the triangles we are taking? If you can mention at the top, that would be great. Like this. So what are the triangles you are taking? That makes more sense. Next, side BC is congruent, and here I am writing equal to sign. Side QR. So now we are taking three elements and we are proving that they are equal. Okay, then I can say that these two triangles are congruent. By which postulate means you can see that by RHS, right angle equals to right angle, hypotenuse equals to hypotenuse, and side equals to side. Therefore, we say that RHS. But some teachers, instead of side, they say that this is one of the legs of the triangle. So instead of side, they say that leg BC is equal to leg QR. Instead of side, they say that leg. It's one and same. So you can say that HL, hypotenuse. Friends, remember, hypotenuse means that is side opposite to 90 degrees. So there's no point mentioning once again about the right angle. Therefore, HL, that is a hypotenuse leg, that is called as HL postulate 2. Okay. Now, let me quickly jump to my worksheet and take, by the way, some rules. Over a period of time, I realized that if you can understand these points, these 9 most common properties, you will never make a mistake. Please remember, you look for the common side. Whenever two triangles are joined together, you may see something common to both the triangles. That I'll explain when I take the questions. Okay. So my apologies. Let me jump back to the worksheet again. Yes. So here is my worksheet. In the beginning, you see that what is congruency and what are these postulates: SSS postulate, SAS, ASA, and RHS. And already I mentioned that there are some 9 points. Oh my gosh, this 10th point too, that is, do not assume anything if it is not in the given or in the diagram. Okay, so let me take a couple of questions. Okay, let me copy this to my whiteboard. So write a two-column proof, write a two-column proof. Given RS is congruent to UT. So please always read the question carefully and then mark the parts. If it is already marked, so let me mark it again. RS is congruent to UT, therefore UT is here. Okay, and RT with a single stroke and US, these two are marked. So I see that two triangles. If you want, you better shade them so you can better understand how many triangles are there. So here is one triangle, here is one triangle, and the other triangle is unshaded. Let me shade this one too. These two are similar colors, blue and green. Okay, so I see that two triangles. So let me write that this is T chart or two column proof, and we write that the statement here, and we, to support our statement, we write the reason here. So let me take first TR, side TR equals to side US. Please see that, okay, let me move this one a little here. Okay, this would be better to write like side TR. It is not necessary just to, I'm writing so that it will be more stronger. Side TR and US. You can see that the sides are marked. How do you know? It's given. Which triangle are you taking? One is triangle TRS, and what is the other triangle? Triangle SUT. Okay, so side TR equals to US and side RS, is congruent to side TU. You can see that these are given in the diagram. Okay, so I proved that side equals to side, side equals to side. And what is the third element? Can it be RHS? No way. Can it be SAS, ASA, and triple S? This is how I think. So if I take ASA property, also not possible because there are two angles, but already I got side equals to side and side equals side. So there are two sides. So it could be SSS or SAS. So just now I shared with you that you please look for, my apologies, please look for something common. You look at the first diagram, I see that both the triangles are together. And I see that there is a common side, like you can see that AB and BA. Then we call this as a reflexive property. So here in both the triangles, I see that this side is common. That means both the triangles are sharing this side, right? So you can write that side ST, you can write backwards, or maybe you can write in the same way, side TS, it's one and same. So these two are congruent by SSS congruency. But one more thing, don't forget, you have to write them in the same order. For example, if I start with say R, I see that this R is in between the given two sides, right? Therefore, you have to start with U because this angle is, this point is in between the given two sides, right? So if I start with R here and the other side, I have to start with U. Then after that, I'm going to my right side, which is S. Therefore, or else maybe can I say clockwise? Yes. Then I have to go clockwise. That is next letter T. Therefore, if I take S here and then I have to take T here, and then please notice that I'm going clockwise. So it is RST, and here I have to go clockwise UTS. Therefore, these two are congruent. I'm done with this question. Okay, questions. Okay, so let me go to the next one. Just randomly, I'm taking a couple of questions. So let me take this question. Okay. Here, I see that two triangles once again. So let me mark them. Oh, already they are marked. So let me shade these two triangles with two different colors so that I can sense it what are the two triangles clearly. So I'm using different colors. Okay. And let's focus on the markings. Let's focus on the markings part. Let me make a T chart. So first one is the statement, and the other side it is the reason. So reason means to support your answer. Okay. Right. First one is let's focus on this one, the markings. So here's CD and let me move this one a bit here. So CD and AB. So which triangles here am I taking? One is triangle. Oops, I'm sorry. Let me take a triangle ACD, and the other one is CAB, triangle CAB. Now, in these two triangles, I see that side CD is congruent to side AB. Okay, that's it. Nothing else is given. But I see that here arrow mark. This arrow mark indicates that these arrow marks are indicating that line segment AB is parallel to CD. These arrow marks are indicating that the sides are parallel. Okay. Now let's see that. Let me think of parallel lines. If I think of parallel lines, then here this angle, though it is not marked, I know that this particular angle, which is BAD, and angle ADC, these two must be equal. Do you know why? You may think of the parallel lines. So let me draw parallel lines here. Let me take the same way. So here, if I'm taking the parallel lines this way, I know that this angle, which is on the right hand side of the transversal, equals to the left hand side of the transversal. But if you look at the diagram, for sure that one leads to some confusion. But let me eliminate this part and this part, this part. Now you see that it's in the shape of Z. These two angles are equal. Why these two angles are equal means because these two are alternate interior angles. These two are alternate interior angles. You learned in the previous classes. So I say that please don't forget, don't use a single letter to name an angle. So let me write that angle BAD. Angle BAD is equals to angle ADC. So please use three letters, not a single letter. So here I'm using angle BAD. My bad, it is supposed to be on the other side. So it is ADC. Makes sense. So here angle ADC and angle BAD are equal. How do you know? Means alternate interior angles. Alternate interior angles. My apologies. I forgot to mention that it's given. And already I told you that if two triangles are drawn together, they are attached to each other, you can see that one side is shared by both the triangles, that is AD in this case. Therefore, I can say that side AD is congruent or equal here, side AD and AD. So how do you know that these two are equal? Means by reflexive property. So side angle side. So is it by side angle side? Are you sure? Please don't forget, if it is Sss property, you have to take extra care whether the given angle is it in between the given two sides or not. That you have to check. Yes, it is. Therefore, it is obeying Sss congruency. It is obeying Sss congruency. Let me take one more question from the worksheet. So this one. Let me take one more question. Well, write a paragraph proof. But I personally prefer, drawing the T chart. That one makes me, this is more comfortable method for me. So let's not change the strategy. So let's take this way. This time I see that given V is the midpoint. Midpoint means that the point that divides into two equal halves. So here YZ, I see that here is YZ, here is YZ, and this one V is the midpoint means this one divides into two equal halves. So I can say that YV side YV equals to side YV equals to side VZ. How do you know side VZ? Oops, I forgot to write the heading at the top. These are my statements. These are my statements. And here is the reason for that. How do you know means V divides. Instead of divides, let me use the correct word. V bisects. Point V bisects. Bisect means into making the given side into two equal halves. So V bisects YZ. And next, and also V is the midpoint of WX. So you see that this is the WX and midpoint means that divides into two equal halves. So I see that WV equals to VX. So side WV equals to side Vx. How do you know means here V point V bisects Wx. Well, so already I got side equals to side and side equals to side. Therefore, it could be SSS because there are already two S letters, or it could be SAS because there is side and there is side. Okay. It cannot be RHS and it cannot be ASA because I don't have two angles. No, I don't have a right angle here. So if I want to prove SSS, third side and third side, are they equal or not? They are neither marked equal nor I don't know why they are equal. So it cannot be SSS. So how about SAS? SAS means the angle in between the given two sides. Oh my gosh, these angles are not marked. But I know that just by marking these two, I can sense that these two angles are equal because whenever two straight lines intersect, vertically opposite angles are equal. Vertically opposite angles are equal. By the way, these angles are marked in between the sides. Please notice that these two angles are marked. These angles are marked in between the sides. Therefore, I can say that it is an included angle. Don't forget you have to use three letters while naming the angle. So here, angle YVW, angle YVW. I'm trying to write in between because to make SAS property. Angle YVW equals to angle XVW XVZ is XVZ. Okay, how do you know means they are vertically opposite angles. Vertically opposite angles. Okay, well. So by SAS congruency, please remember the order is important. Let's say that if I'm taking say triangle XVZ congruent to, please see that I'm taking, I'm sorry, I'm starting with X and I'm going clockwise direction. Therefore, here the angle X, you know that that is equals to W. So we have to start with the W, triangle W, and let me go in clockwise direction. So it is WVY, WVY. These two triangles are congruent. Okay. Okay. Okay, guys, that's it for me for